3 centuries ago, the world experienced the first industrial revolution. It started in Great Britain, but would end up spreading far beyond, becoming a turning point for humankind. The invention of the steam engine catapulted innovation and mechanized production, leading to groundbreaking products like the light bulb, the calculator, and even the sewing machine. Later, modern societies entered the second industrial revolution, where electric power, petroleum, and steel significantly increased mass production and railroad development. In the late 20th century came the era of digital evolution, where electronics and computers propelled the digitalization of production processes and widespread globalization. It was the dawn of the third industrial revolution. This butterfly effect of technological evolution has led to more recent speculations on whether some countries were already bracing for a fourth industrial revolution. Innovation has exponentially increased pace, and we are now more connected than ever, with almost all the information in the world available at our fingertips. Such instant connection capability has also hit the industrial sector. With smart tools and robotization emerging, many industries hasten to incorporate them into their processes, be it in the optimization of product manufacturing chains and tools, or the control of a machine's mechanical properties. This way, we may have entered the era of intelligent manufacturing. One of the ways to control the quality and integrity of the tools is through the placement of sensors to evaluate parameters such as pressure and temperature, which can be quite challenging to do without reducing the effectiveness and accuracy of signal acquisition due to positioning problems. For that, the placement of thin film sensors in the desired location has been studied as an hypothesis. Thin film devices are made of very thin layers, ranging from nano to micrometers in thickness. They can be made of different compounds and are deposited on surfaces to alter their properties and create objects such as solar panels and mirrors. The deposition of these layers must be done in a way that protects their mechanical and electrical integrity. In today's podcast, we will find out how industry-driven research is addressing this challenge. Hello, and welcome to another episode of Crosstalks. My name is Adriana Costa, and I will be your host. This podcast series by the UT Austin Portugal Program will walk you through the wonders of science-business collaboration. We will be exploring emerging topics in advanced computing, medical physics, nanotechnologies, space-Earth interactions, and technology innovation and entrepreneurship as we delve into the program's industry-driven research projects. There are more than a dozen techniques to deposit thin film layers onto a surface. When we want to deposit metal and oxide films to coat tools for optical and electrical purposes, professionals use sputtering, a common type of physical deposition technique. Now, imagine sputtering as a game of the hit arcade game Space Invaders. But instead of shooting lasers at your targets, you are actually shooting ions. These ions attack a target made of thin layer material, liberating molecules that will move and deposit onto a substrate to create the desired thin film layers. Although Space Invaders is quite easy and simple to play, when producing thin film layers, and more specifically thin film sensors, sputtering encompasses many manufacturing steps that need to be efficiently controlled and optimized to originate a successful product. For that to happen, the UT Austin Portugal Strategic Research Project Soft4Sense is combining experimental work and simulation to create software able to supply the necessary information for depositing thin film devices without mechanical or electrical integrity problems. Today, we invited the masterminds of this international collaboration to coat us with the interesting science behind this project. Bruno Martins and Patacas, both researchers at Instituto Pedro Nunes, and Rui Huang, professor at the University of Texas at Austin's Cockrell School of Engineering. So welcome and thank you for accepting to join me today, and I hope you're doing well.
Thank you. Thank you for inviting us.
Hello, Adriana. Thank you for inviting us and the opportunity to talk a little bit about the project and what we can achieve when a chance is given to us.
So to start, some experts claim that with the increasing digitalization of the world, and particularly the industries, we have entered the fourth industrial revolution, which can also be called Industry 4.0. I would like to ask Bruno, what is your opinion about it, and how can the Soft4Sense project play a part in this new era?
So thank you for this question, Adriana. By the way, nice presentation of the thin films technology. I just would change the Space Invaders by Star Wars, but it's okay anyway. So answering your question, Industry 4.0 and IoT, which we call Industrial Internet of Things now, are side by side since the last year. So we are at this moment in the digital manufacturing era, which means that tools are equipped with sensors to improve the process and then, of course, increase the productivity, which means less waste production, and the better use of the resources, and of course, the key ingredient that today everyone speaks about is energy efficiency. So we believe that we can find a mix between connecting the machines, cloud computing, artificial intelligence to assist in these process decisions. However, the foundations, what will support this leap in technology is always data. Digital manufacturing is not possible without sensors. And with this project here is where you can use thin films technology to position sensors like, for instance, temperature, pressure, just to name a few, in crucial zones of the processes where we don't have the availability of these sensors in the market. And with this, we can have reliable readings, which in these sensors and these materials will withstand pressure, temperatures, or atmosphere in corrosion, for instance. We believe that Soft4Sense will have significant outcomes, at least two sensors to give us reliable data, and the strategies to development these sensors.
Okay, thank you, Bruno. I am not a connoisseur of Star Wars, so I'm gonna watch it first to see if I can have any parallel with the project.
Yes, you should.
Okay, I will. So the Soft4Sense project presents itself as a solution to help the process of thin film layer deposition in cutting tools while maintaining their integrity, which is something that you have mentioned before. And this time I would like to ask Carlos, why is this a critical problem that is worth researching and worth of the research community's attention? And second, who will most benefit from this solution that you have, and to what extent?
Okay, this actually is a tricky question. And it's tricky because of one or two things. The first part is that it's not just worthy for the research community. In fact, there is already a lot of scientific papers and patents, submissions, and in fact, it is very important. But what we can actually see up to now at these technologies, this way to try to find a solution for this kind of problem, just happens at a lab. But in a laboratory, usually you can have a very well-defined environment, and it's very easy to accomplish what we want. The problem, the big question is in fact to go outside the lab, to actually have a solution in the industry. Okay, so this is the biggest problem, and to make sure that whatever we can do in the future for the industry makes a product which can be applied and to be, of course, a cost performance relationship. This is the first part. But then again, the processing steps are limited. We can try to accomplish this to have a very good product, but there are a lot of limitations. Of course, this idea, just the way as we think of this, we have to apply a multi-layer technology. We have to have multiple layers just for the sensor, and to make sure that all the system works fine, we need to be careful with how we can do it. And this is the reason why we are going to have this project, and this is the best part of it. And of course, smart tools are a complex product, which means that all of supply chain, all the chain, the value chain are important, and everyone take advantage of this system. So just all of them, just to name just a few eventually, developers, job coders, tooling vendors, software and electronic suppliers, machining workshops, all of this value chain actually can have an important role and benefit from this project.
It is very interesting to see that this can actually help the industry in a whole new level that I would not imagine, which is by taking this off to go outside the laboratory, how many people and industries can be benefited from this. When we have a control setting, yes, it's much easier to get the results that we want, and I think this goes for almost all research areas. I think it's easy to say, for example, in the health research community, my background is in health research, so I know that being in this very controlled environment is very easy to get what we want. But once we go to patients and human samples, for example, the history and the complexity is a lot higher. So I understand completely the challenge that it is to go beyond the laboratory.
Yeah, and the worst is in this case is, of course, all of this is even worse because we have a very harsh conditions when we do cutting and machining. So we actually require a lot of properties that usually for a lab, for instance, in this environment, it's not so problematic.
Yeah, that's indeed true. Okay, another question. In order to aid and optimize the thin film deposition process, you are creating software to retrieve several types of information. What information is important to retrieve to understand if the deposition process has been successful?
Okay, I guess I can take on this question. Again, happy to be here to talk to you about this project. So thin film technology has been around for quite a while in very many different industries. I think the application cutting tool is kind of new for me. I've been working on thin film research for almost 20 years now, but mostly in the electronics, flexible electronics area. Nevertheless, we know from our experience, both academic and industrial, different deposition processes. There are many different processes, and also parameter can lead to very different electrical and mechanical properties of these deposit films. And for cutting tools, these properties are very important, especially in this project. We're trying to develop the very sophisticated sensor systems requiring very specific electrical properties and also mechanical properties to protect these sensors. So in order to do this, I think our goal here is to be able to create a software that can identify the optimal parameters to achieve the desired properties for these cutting tools. This, of course, requires a very good understanding of this, the relationship between the process, structure, and properties. So these are the three sort of components of this whole development. And so in order to do this, we also have to retrieve this data and information, such as what kind of microstructure we get from each process, and what kind of temperature-dependent electrical resistivity, as well as mechanical properties such as hardness and toughness. So put all this in together, we're trying to establish this process structural property relationship so that we can kind of feed back to the software to identify the optimal process parameters. So that's the idea.
Thank you, Rui, for your explanation on what information is important to retrieve for these processes. Would you like to add anything, Bruno?
Basically, the idea is to target in advance the process parameters to achieve a reliable procedure. And then this will allow us to shorten the distance between the laboratory depositions and the industrial depositions. So we can go, for instance, to T&M facilities and then integrate the process in their equipment. So, okay, we'll always have a learning curve, but should be more easily to integrate this process in different machines.
Thank you, Bruno. I would like to ask Rui in simple words, if you can explain to our listeners the intricacies of your project and the software that you are developing, and what does the software do to collect the necessary information?
Okay, so as a part of developing the software, we are collecting the data to train so-called machine learning model for the process structure property relationship. So these data are collected from measurements of the electrical and mechanical properties of the deposited layers, as well as we have detailed microscopy images with microstructures. So based on this data, the software will link the process parameter to the properties of the film. So then at the end, we would like to solve an inverse problem using the software to determine what are the optimal process parameters if for specific applications that require particular electrical and mechanical properties. So these are two parts. First, we develop a sort of a forward problem, like based on the process parameters, structures, and properties. We establish a relationship, and then we solve an inverse problem for given applications, the properties we're trying to find out what are the deposition properties we need to achieve those properties. So that's the main idea.
Thank you, Rui. It's amazing how many things the machine learning can do in many different contexts. So the software you are developing is intended for the evaluation of the thin film sensors deposition in the coating of cutting tools. Once this software is fully developed, could it be used for other applications or tools, or is it specific for cutting tools?
Yeah, so this project, I think it's also a kind of industrial consortium project. So it's targeting the specific application, the cutting tool. So essentially the problem is brought to us from this cutting tool industry. But the approach with developing the software can be more general. It can be extended to other applications, the development methodology, right? Of course, we have to understand that every different applications, they have different requirements for these electrical, mechanical, or other properties of the films. So therefore, in order to extend this software for other applications, we will have to collect additional data and to train the machine learning method to for each specific property application, essentially. So that's a requirement. Yeah.
Could you give me a specific example of where it could be applied? For example, we have cutting tools. What other tools could it be implemented? Do you know?
I can add something on that. For instance, like Professor Rui said, this model as always must be trained, because things happened at the very beginning in the substrate, which is the real surface. So, for instance, this type of sensors could be applied in injection molding, for instance, where the temperature is very critical for the polymer into the actually temperature and pressure, of course, to the compactness of the polymer inside the mold. But anyway, ultimately, if we can aggregate these different layers to achieve a sensor, so I think the opportunities for these smart sensors are endless in the future.
That's very, very, very good, I would say. And if the project is successful, it can reach a lot of industries altogether. This project results from the collaboration between the stakeholders in Portugal and Texas. I would like to ask Professor Rui, what are the strengths of each stakeholder that make this project go further? And were there moments when you felt that this international cooperation was crucial for the project's success until now?
Right. Of course, this project would be impossible without all the groups in this cooperation, including, I think, 3 groups in Portugal and 1 group at UT Austin. Each group plays an essential role. So as I mentioned before, we're trying to develop this process structural property relationship. So this relation is very complicated. In fact, many of the material research is trying to achieve this for different kind of materials and applications. So for example, the industrial, our industrial leader, it's T&M, is as an end user of the technology. They basically bring this problem to us and guide our research and development with a very specific target, right? So application. So we have to, whatever we do, we try to make sure we meet their needs, essentially. IPN, as these Bruno and Carlos are in, they're the film developers. They deposit film, they optimize deposition process, and characterize electrical properties. That's one important part of this project, so that's providing sensory functionality, right? And the other Portugal group, INL, they are expert in this microscopy. They can provide us with detailed images of microstructures with the film and interface, so we know the composition and the structure as a result of different deposition process. The group at UT Austin, including me and another professor, Dr. Ken Lichty, and a couple of students and a postdoc, we're responsible for mechanical assessment and simulation. So we're trying to understand the mechanical properties and simulate how these films respond to various interactions with the environment. So this collaboration of workforce is all needed for this project to succeed. And also, it's quite challenging because we have had this for almost 3 years now, 2.5 years, but much of this time is in pandemic. So we haven't been really get together in person to exchange ideas. So that's a bit of a challenge, but still, I think together we have been able to make some steady progress with the regular and frequent teleconference and email communications. We have exchanged samples and results and research results. So we're toward getting to the final stage of the project. We hopefully will get to finish it well. Thank you.
Thank you, Rui, and that's exactly where I was going. Because yes, you are in the final stages of your project. The Soft4Sense project is set to be finished in 2023. I would like to ask Bruno, what are the final results you expect to achieve until there?
In our case, at IPN, we at least want to finish 2 PhDs, my own and my colleague Carlos. We are working on this on different subjects, but they are interconnected in the flow of this research project. So scientific publications, of course, and at least a patent submission that we already have a draft for a provisional patent, and our ultimate desire is to demonstrate the cutting tool complete functionality in the industrial environment, and that is foreseen for as a final result in the project.
Thank you, Bruno. I hope that you are successful in accomplishing all these tasks that you have for 2023. I would like to ask if Rui or Carlos want to add anything.
Yes, I can add a few things. I think from UT side, we are also working on a couple of journal papers to publish our research results, as well as the software development. Now, in the academic setting, of course, the other important part is supporting PhD students and their work toward their degree. We also have a postdoc fellow that have been worked on this project for almost 2 years. I recently left for a faculty position in the US. Now, the PhD students we have on the project will continue working, even though this project is ending next year, but they have started working on this project. They will continue with working on the related areas for their final dissertation.
And that's amazing that this project has or can give opportunities to students and to continue the research beyond the completion of the project. And that's where I was going to as well. So since technologies like this take years to develop, and that's why you have to continue this project beyond 2023, I would assume. I would like to ask if there are actually any plans to continue this collaboration beyond March 2023.
I can start with that. I think we've been talking about this right now. We don't have any specific plan. I certainly hope to continue this cooperation with our Portugal partners. So as I mentioned, the student, at UT, obviously, they will continue working in this related area for at least 2 or 3 years. We're looking for some programs in either Europe or US to continue to support this effort. Now, from US side, I think NSF has a program called Designing Materials to Revolutionize and Engineer Our Future. This is a relatively new program in NSF. I think could be a program of interest for us to seek some financial support and funding to continue this type of work. But at this point, I think this program is not designed for such an international collaboration yet. So we still try to figure out how we can continue this international collaboration. I think there may be some opportunities in Europe or US. We'll keep looking for that. Yeah.
I truly hope that we are able to move along in the future with this project, especially together with Portugal and Texas united to make this project even more successful. Is there anything that Bruno or Carlos wants to add?
Well, to be honest, I think everything is almost said, almost everything is said, because the truth thing that what we can actually fight is to find funding so we can continue to target some specific goals or for further developments. Because in truth, what we can say is the team is created, and of course, with this project, we can say for sure that the team works. And the most important part is that all the, let's call it value chain in this project, all the knowledge that is necessary is there. So for sure, this project could actually follow for a further development, for sure.
I'm glad that can be a reality, and I hope it is a reality. Thank you very much for being with me today, and thank you for spending a little bit of your time explaining more about your interesting project. This conversation was as fruitful as your project is, and I'm very excited to hear more updates in the future.
Thank you.
Thank you.
Thank you. Thank you.
Thank you all for listening to this episode of Crosstalks. If you have enjoyed it, and even if you did not, we would love to hear from you. So make sure to subscribe and leave a review. For additional content, follow us at UT Portugal on Twitter or visit utaustinportugal.org. Did you know that we are now also on Instagram? Make sure to follow our journey there at utaustin_Portugal. The Soft4Sense project consortium brings together scientists and business people from 4 institutions: TENM, Instituto Pedro Nunes, the International Iberian Nanotechnology Laboratory, and the University of Texas at Austin's Cockrell School of Engineering. Soft4Sense is co-financed by the European Regional Development Fund through Compete 2020 and the Portuguese Foundation for Science and Technology, bearing the seal of UT Austin Portugal. The total eligible investment is around 1.7 million euros, with public funding amounting to 1.61 million euros. UT Austin Portugal is a partnership program in science and technology between the Portuguese Foundation for Science and Technology and the University of Texas at Austin, supported by the Ministry of Science, Technology and Higher Education in close collaboration with the Council of Rectors of Portuguese Universities.